All right, we're going to talk about transforming polynomials. We've talked about transforming quadratics and cubics. Now we're going to talk about general, okay? So that's the translation up vertically, horizontally, vertical stretch, vertical compression, x-axis reflection. So I want to transform y equals x cubed. And this is how I want to transform it. Okay, I want to have a vertical compression. So the vertical compression starts me off on the path that says if I want a vertical compression, I'm now going to go y equals 1/2 x cubed. Okay, so my first piece took me to this. Now it said an x-axis reflection. Well, if you remember, the x-axis reflection says, oh, okay, I now have to negate my coefficient. Okay, so now I have -1/2 x cubed. It says a horizontal translation of 3 units right. So that's going to be now, I'm going to have to go inside. Remember, horizontal is inside with the x. So x right is +3. So +3 is going to make that 0. So it's x minus 3 quantity cubed. And then it says vertical translation 2 units up. So y equals -1/2 x minus 3 cubed plus, because I'm going up, 2. There's my transformation of a vertical compression of 1/2, an x-axis reflection, a horizontal translation of 3 units right, a vertical translation of 2 units up. There's my equation. Y equals -1/2 times the quantity x minus 3 quantity cubed plus 2. Now, how many distinct real zeros does this function have? Distinct real, okay? So that means not talking about multiplicity here because we want them to be real. So what we're going to do is we're going to set y equal to 0. And I'm going to solve this now for x. Well, the first thing I need to do is get my k to the other side. Okay, oops, that's supposed to be a plus. So I'm going to subtract k from both sides. So I get -k equals -a x minus h quantity cubed. I'm going to divide by -a. So now I have k over a equals x minus h quantity cubed. Okay? I'm going to flip this around though so we can have x equals. Okay? So how do I get rid of a cube? I cube root it. So now I have x minus h equals the cube root of k over a. Well, how do I get rid of the h? I add h. So now x equals the cube root of k over a plus h. There's my answer. Well, if a, h, and k are real numbers, this is going to give me a value inside here, right? K over a is just some number. I take the cube root of that number, I get a number. I can take the cube root of positive numbers, negative numbers, I get the cube root. And if I add something to it, I'm only going to get 1. Okay, so there's one distinct real zeros in this function here. Okay? So the next thing is what is the quartic function with zeros at x equals 5 and x equals 9? Okay, so we have to understand what does an x to the 4th power looks like. So it almost looks like a parabola, but it's kind of thinned out and goes up. Okay, so it's very similar to a parabola. Now, when we start, we only have a 0 at 0. So, but what we're going to do is we're going to look at moving this. We're going to have to move it down some, but we're needing to have those zeros be at 5 and 7. Well, the nice thing about x to the 4th is x to the 4th is symmetric. Okay, so you have to understand that it's symmetric through that vertex, okay, through that 0. So that tells me how much I'm going to be shifting it over. Because when I look at 5 and 9, since these both have to equal 0 when I plug it in, my horizontal shift has to be halfway between them. Well, what's halfway between 5 and 9? Well, that's going to be 7. So now I know I'm x minus 7 to the 4th plus some unknown. And I'm going to put plus k here, right? Because I have some unknown, right? So I know I've shifted it. I've taken this and I've shifted it over, but I have to shift it down some now. Well, remember that if I plug in 9, this has to equal 0. 9 minus 7 to the 4th plus k has to equal 0. So this gives me 2 to the 4th plus k. 2 to the 4th is 16. So k has to equal negative 16. So now my function is y equals x minus 7 to the 4th power minus 16. So to get this, you just need to make sure you understand the properties of that even quartic function, okay? So we've talked a lot about transforming polynomials, okay? We've talked about how to vertically transform them, how to horizontally translate them, vertical stretch and compression, and reflection over the x-axis. We actually talked about reflection over the y-axis. We're not going to deal with that in here, though.